And welcome back, students. Now we are finally getting into being able to run a program using the LC-3. So previously, we've created programs using the LC editor to write programs in binary, hexadecimal, and assembly. Now you're ready to run your program in the simulator. So we're going to open the simulator and then click on the Load Program button. We're going to browse and we're going to choose our addNum1.obj. This is our binary version of the program. And notice that you only get the option to open one type of file in the simulator, .obj. You're not going to see anything like .hex or .binary or .asm, regardless of which one you're trying to load. So what you'll see is when you load your program, you'll see something very similar to this. Now, notice that the first line of your program is gone. That line specified where the program should be loaded in memory, x3000. As you can see, if you scroll up a line or so, the locations for 3000s are still all 0. So even though it starts at 3000, you can actually go up to x2999, and you can see all those in there. Now, since nothing has happened yet, you haven't started running or stepping through a program, the temporary registers R0 through R7 still all contain zeros. The program counter is still pointing to the first line of your program as 0, and the IR is also empty. So let's actually look at loading the data into memory. There are some ways to get the 10 numbers that we're planning to add into the memory of the LC-3 editor or simulator. We want to begin those at location 3100. So the first way is that we can click on the Jump To box in the right buttons on the toolbar and type the hex number 3100. When you press return, you'll jump 100 locations ahead in the memory display so that the location 3100 is also shown. Now double click anywhere on that line, 3100. You'll get this pop-up window. And it's going to ask you to change the value. In the value box, you're going to type the hex number 3107 and choose OK. Now your first data location is going to end up looking like this. So at 3100, you're going to see there's the x3100s. That's the binary representation, remember? This is the hex representation, and it's saying ST is to store, and it's using register 0. Now loading data into memory, continuing on, you'll notice that we get the binary hex representation, some silly uses assembly languages, so we got the ST right there, as I mentioned. All right, now the important thing to note that this is data now, not instructions. So the stuff that we did previously was write the instructions. We didn't do anything with data. We didn't do a single thing. Right? This now is data. But the LC-3 simulator doesn't actually know that. It has no way of differentiating between data and instructions. In fact, the contents of all memory locations are equal in the eyes of the LC-3 until they get run as instructions or loaded as data. Now, since we have a halt instruction far before the place that we're putting all this data, it's never going to be treated as instruction. So this program is going to start at location 3000, going to run through, it's going to hit the halt command, and it's going to stop. So if the halt command had not been there, it would have went through treating everything as instructions until it eventually reached a halt command. Now we can double click on each line in turn to enter the data. So we start at 3100, and then we can go down to the next line 3101, 3102, so on and so forth until we have our 10 numbers in there. If you only want to open the pop-up field window once, we can keep changing the value of the location field. So I could just change it to 3101, 3102, and then just enter the number in the field value below, and then click the apply button. When we're done, we just click OK. Now that way it can be kind of tedious. It's not bad if you're only doing let's say 1 or 2 numbers, but when you're looking at bigger numbers here, like here we have 10 different numbers to do. All right, that can get a bit tedious. So one way to do that is to go into our LC-3 editor program and enter the code in hex. So here I have 3100, 3107, 2819. All these different numbers are in here to represent the 10 numbers that I want to add. Now you'll notice that the 3100 is the starting location in memory, because that's always what it's going to be. It's like, hey, that first number, no matter what, is your starting location. So you never want to make it the first number. You want to add the starting number. Then you're going to save that as data.hex. All right. Again, the first line of the program is where we want our data to begin, 3100. So let's convert that program from hex to generate the data.obj file. Then we're going to load our new data.obj file into the simulator, and note that you can load multiple obj files into the simulator. All right, once that's loaded, you can see the memory locations will look as they do below in this image here. The data is in place, so let's go ahead and run our program. All right, so let's talk about running the program. So we're going to click on the jump field and choose 33,000 as the location where we want to go. The next step is very important. All right, double click on the little gray square in front of the line address 3009. Now remember, that's your halt command. All right, so we're going to double click right there. What that's going to do is it's going to set a breakpoint on the line. If you don't do this, you're never going to see your result in register 1 because we'll do the trap routine for halt, which changes register 1 before it halts the simulator. And we'll explain more about breakpoints in detail later. All right, after you double click the line, of course, it's going to look like that. The little red circle kind of appears there. That red blob, of course, is representation of a stop sign. So we get to line 3009 before we run any instruction there. All right, running the program, we are now ready to do so. So make sure the PC, or the program counter, has a value of 3000 because that's where the first instruction is. If it doesn't, double click on the value there and change it to 3000. Now run the program icon and you should see an answer of 8,135 in register 1 when the program stops at the breakpoint. You'll get a pop-up window telling that you've reached a breakpoint, which in this case is the event when the program counter gets the value of 3009. All right, so that's the end of the notes. So let's go ahead and just really quickly, I want to show you what this would actually look like using the simulator here. So I'm going to go ahead and I'm going to choose to load off the desktop here our file from before. So we want our addnums1 obj. So when I click on open, you can see now in here I have some registry values. You can see there's my add, my AND, my LEA, LER, add, BRP, and trap values. Those are all now loaded in my register. And that is how simple it is. Now, we did talk about being able to jump. I can use this, you have this jump to command, stuff like that. All these different things that I can do in order to change values. I can double click on values, and you see if I double click on something, it says location. I can choose to type in there that 3100, and then I can set the value manually, which I believe we said we wanted to set that to 3107 or something like that, but it doesn't really matter. So I'm just going to do that. If I click on OK, if I were to jump to that location, right, you can see that it has stored that value in there. However, this, of course, is going to be very tedious to go through in each one of those numbers and do it, especially if I have more than 10. So what I'm going to go ahead and do is I'm going to go ahead and open up the LC-3 editor. I'm going to make a new program, and I'm going to go ahead and type in that data.hex file that we had discussed previously in the notes. All right, so the numbers are in there. So I'm going to go ahead and click on save, and I'm just going to call this data.hex. And remember, this first number here is going to be where that data is going to be starting. So this is actually not a number that's going to get added here. So I'm going to go ahead and click on the conversion button. And converted with no errors, so that's a good sign. And I'm going to go back to my editor here. And what I'm going to do now is I'm going to load that data file. So here's my data.hex. That's now data.obj. Click on open, and you can see it's now populated in every single one of those numbers for me, which is very handy. It's a lot faster than having to go here, double click, type it in, double click, type it in. I personally prefer just creating a file and then loading it. It's a lot faster. All right. Now let's go ahead and jump this back to location 3000, and you can see it kind of keeps it here stored for me, which is pretty nice. And we wanted to add a breakpoint at line number 3009. So I just double click on that tiny little dot there, and it makes it a red X. Right? So now my program is ready to go. So all I'm going to do is I'm going to come up here to where this green arrow is, and you can see it says run program. So I click on that, and the program has executed. Right? And you can see this looks a little weird. So the one thing I might have forgotten to do, remember, was to change the program counter, because remember, you have to watch that there. So what I'm going to do is I'm actually going to reinitialize the machine here, just blank everything out, and let's go ahead and reload addnums, and I'm going to load data, And you can see what happened is that the program counter was 3100. So this is something you want to make sure. So even though I did the jump 2, the program counter was at 3100, which means it did not run the code correctly. So I'm going to double click on that and change that back to 3000 because that's where I actually want my program to start. Add my breakpoint, and I'm going to choose to run the program now. So now, breakpoint encountered, which is what we wanted to do. I click on OK. And if I look here in register 1, there is the value I'm looking for, 8,135 in hexadecimal, or negative 32,459 in decimal. So that's all there was to it, folks. All right, until next time.